In this video, we're going to compute indefinite integrals. So our first example is the integral of sine x dx. So this problem is asking for a function whose derivative is sine x. So when we get an answer, we can check our answer by saying the derivative of our answer is sine x. And we're going to guess the answer based on our knowledge of derivative formulas. So I know that the derivative of cosine x is negative sine x. So I think a good guess would be negative cosine x. So the derivative of negative cosine x would be negative sine x, and the double negatives cancel and we get sine x. So this is correct. But this is not the only answer, because there are functions whose derivative is 0 that we could add on, and those are constants. So negative cosine x plus any constant is also going to work. And we're just going to put a c here for our constant, and that's called the constant of integration. For the second one, we want the integral of the cosine of 3x. And this 3 here is throwing me off. If it was just integral of cosine x, I would guess sine x plus c, because the derivative of sine x is cosine x. But here we have a 3x, so I'm going to guess sine of 3x. Then the derivative of the sine of 3x is equal to the cosine of 3x times 3 by the chain rule. Derivative of the outside is cosine times the derivative of the inside, which is 3. So this is almost correct. I just don't want this 3 here. So I'm going to modify my guess to be 1/3 times the sine of 3x, because if I squeezed in a 1/3 here, then my answer would have a 1/3 sitting there, and 1/3 times 3 is 1. So by guessing, modifying, and checking, I've come to the conclusion that the integral of cosine 3x with respect to x is 1/3 sine 3x plus c. And for the last one, we have the integral of secant squared x, and the answer here comes from knowing that the derivative of tangent x is secant squared x. So we're just reversing this derivative formula. So the integral of secant squared x dx is the tangent of x plus any constant.